Morning to one and all. Today we are going to present maths activity on unit number 5. Our group members are Pranav Pawar, Shruti Pawar, Mayur Pawar, Shravani Porje, Rohan Rathod, Ikira Sheikh, and I am Raksha. So firstly we'll start with definition. Any rectangular arrangement of numbers, real or complex, is called a matrix. If a matrix has m rows and n columns, then the order of matrix is said to be m by n, denoted by m into n. The general m into n matrix is represented as following. The sum is also called as a trace of A, denoted as the following. Thank you.
Hello, my name is Shruti Pawar and my topic is rank of matrix. Matrix is said to be of rank R if there is at least one minor of order R which is not equal to 0 and every minor of order R plus 1 is equal to 0. It means that for a matrix to have rank is equal to R, there are two conditions. First is at least one minor of order R should not be equal to 0. And second condition is every minor of order R plus 1 should be equal to 0. In simple words, it means that rank of matrix is equal to the number of non-zero rows after converting the matrix into echelon form. Now let's see what is echelon form. It is a matrix A in which one or more elements in each of R rows are non-zero and element in the remaining rows are 0. In first R rows, the first non-zero element in each row appears to the right of first non-zero element of preceding rows. Or more than one elements in each row of matrix A should be non-zero and the other elements in
Hello everyone, myself Pranav Pawar. I explain you homogeneous system of linear equations. So first of all, what is a homogeneous system of linear equations? A homogeneous system of linear equation is a linear system of equations in which there are no constant terms. And homogeneous systems are always consistent. And there are two possibilities. Number one, number of rows and number of unknowns are unequal. And number two, number of rows and number of unknowns are equal. In unequal possibility, there are two solutions: trivial solution and infinite solution. In trivial solution, rank of matrix A is equal to number of unknowns, and in infinite solution, rank of matrix A is less than number of unknowns. And in equal possibilities, there are two solutions: infinite many solution and trivial solution. Means what? Unique solution. In unique solution, determinant of A is unequal to 0, and infinite many solution, determinant of A is equal to 0.
Hello everyone, myself Mayur Ravindra Pawar. Today our topic is system of linear equation. There are two types of systems. First is homogeneous system and second is non-homogeneous system. In that I am going to explain you non-homogeneous system of equation. Non-homogeneous system of equation in that not all RHS are constant. That means the equation forms that is Ax equal to B. Then the method to solve the non-homogeneous system. Step 1 is to consider a matrix form. Matrix form is Ax equal to B. Then consider a augmented matrix. By considering a augmented matrix, step 2 is that to convert matrix A into echelon form using row operations only. That means to make the diagonal below the diagonal 0, all elements 0, and whatever row operation we are performing on the matrix A, that should also be performed on the matrix B. Then the last step number 3 is to find rank of A and rank of A augmented B. If the rank of A and A augmented B is equal, then the system is consistent, and the rank of A is not equal to rank of A augmented B, then the system is inconsistent. System is inconsistent means that there's no solution exists, and if the system is considered, there's the two conditions. That means the rank of A and rank of A augmented B is equal to number of variables. That means the number of unknowns. Then the solution which gets that is unique. And the rank of A equal to rank of A augmented B is less than the number of variables, or we can say that the number of unknowns. Then the solution which comes that is infinitely many solution. This was the explanation for the non-homogeneous systems. Thanks for watching my video.
Hello everyone, myself Shravani Porje. I'll explain you about linear combination of vectors and linear dependence. Vectors, linear combination of vectors. A vector x which can be expressed in the form of x equal to k1 x1 plus k2 x2 plus k3 x3 up to kn xn, where k1, k2, k3 up to kn are numbers said to be linear combination of vectors that are x1, x2, x3 up to xn. Next is linear dependence. The set of vectors x1, x2, x3 up to xn are said to be linearly dependent if there exist n scalars c1, c2 up to cn, not all zeros, such that c1 x1 plus c2 x2 plus c3 x3 up to cn xn equal to 0, where 0 is the null vector. If vectors are linearly dependent, then any one of the vector can be expressed as linear combination of remaining vectors.
Myself Ikra Sheikh. I am here to represent you the application of matrices. Mathematics. Matrices are used in algebra to solve system of linear equation and to study vector spaces, linear transformation and eigenvalues and eigenvectors. Physics. Matrices are used in quantum mechanics to describe the state of particles and interaction between them. Matrices are also used in optics to describe the transformation of light as it passes through lenses and mirrors. In engineering, matrices are used in structural analysis to calculate the forces and deformation in structure such as building and bridges. Matrices are used in control theory to design feedback controllers for mechanical and electrical systems. In computer science, matrices are used in computer graphics to transform 3D models into 2D images. Matrices are also used in machine learning to represent and manipulate data and to train models. Economics. Matrices are used in input and output analysis to model the flow of the goods and services between different sectors of the economy. Matrices are also used in game theory to represent the strategies and pay off the players in strategic interaction. There are just a few examples of the many applications of matrices. Matrices are a powerful tool for representing and manipulating the data and for solving problems in wide range of the field. Application of system of linear equation. For solving the laws of electrical circuits like Ohm law, Kirchhoff current law and Kirchhoff voltage law.
Hello everyone, my topic is application of system of linear equation. Let's see. The law of electrical circuit are: the first one is Ohm's law, second one is Kirchhoff current law, and third one is Kirchhoff voltage law. Let's see first one. Ohm's law. The voltage of drop V across a resistance R is V equals to IR, where I is the current flow. Kirchhoff current law. The current flow into the node is equal to the current flow out of the node. By KCL, we get I1 plus I2 minus I3 equals to 0, or I1 plus I2 equals to I3. Kirchhoff voltage law. The algebraic sum of the voltage drop around the closed loop is equal to the total voltage source in the loops. Let's see the uses of the linear equation. Finding unknown edge. Finding unknown angles in a geometry. For a calculation of a speed, distance or time. Problem based on force and pressure. Computing milling rates. Estimating income over